Welcome to Train Signal. You're watching a lesson on wired network media. Now, we learned in a previous lesson that network media can be physical cables or could also just be invisible wireless airwaves. Well, in this lesson, we are going to focus on the physical cables. Now, the first type of cable that I want to talk to you about is something called twisted pair cabling. Now, twisted pair cabling, I will tell you, and beyond anything else, this is the most heavily used cable in local area networks, so in the actual office spaces. Now, twisted pair cabling is broken down into different categories, or as you can see here on the screen, abbreviated to just different CATs. Okay, so you see I've listed here CAT 3, CAT 5, CAT 5e, CAT 6, and CAT 6a. And you'll notice that the biggest difference between them is the speeds. Okay, and these speeds are the maximum data rates that it can handle. So if we start off at the top with category 3, you'll notice that that maxes out at a lowly 10 megabits per second. For that reason, you really won't see category 3 cable out there anymore because you have to go all the way back to like the 1990s to have networks that were considered satisfactory at 10 megabits per second. Really, the beginning of where you'll see today's twisted pair cabling, it starts at category 5. You'll actually hear that term a lot. You'll hear people talk about, do you have Cat 5 cable? Do you have Cat 5 cable? And the reason you start at category 5 is because now you can handle speeds up to 100 megabits per second, which although by today's standards is still on the borderline of slow, it's also considered to be acceptable. There are many of 100 megabit Ethernet networks out there today, and so category 5 twisted pair cabling is perfectly acceptable. Now from there, you'll notice that we have some other categories which will bring you all the way up to 1,000 megabits or gigabit transmissions, and that is much closer to commonplace in today's world. And you'll see going into the future much faster speeds even beyond that. Now the one thing that I will tell you that is the same no matter what category of twisted pair cabling you're using is that all of these cables can only take data. And I will tell you that the data, by the way, one factor of this we haven't talked about is that there are copper cables inside, and we'll look at the insides in just a minute, but these copper wires have electrical transmissions. That's how the data is traveling, and you can only take that data a maximum of 100 meters before suffering from attenuation. Now that's a term that might be new to you, so let's talk just a little bit about attenuation. Attenuation is the dissipation of that signal over distance, and sometimes additional connections can also shorten that distance. Now let me give you an example of what I mean by the dissipation of that signal. As I'm talking to you right now, my voice, the actual sound waves are traveling from my mouth all the way out to your ears. And what that means, if it's making it to your ears, if you can hear me right now, that means that we are in close enough proximity to each other that those sound waves can make it there before they have attenuated. Now, if I were to lower my voice, you may or may not still be able to hear me, but you may have to have gotten closer. You may be closer to your speakers thinking something's wrong with the volume on this video. There was nothing wrong with the volume there. I was talking to you in a much softer voice, and therefore my voice attenuated much more quickly. And eventually, if I were to soften my voice even more, you may. Okay, so that's how attenuation works. Now there's a few other aspects of twisted pair cabling that I want you to be aware of. First of all, as you can see on the screen, there are two different types of twisted pair cable, one called unshielded twisted pair, or UDP, or really what many people just consider to be standard twisted pair cable. And then we also have shielded twisted pair, or STP cable. And I need for you to understand, well, number one, the makeup of these cables, and then number two, the differences between the unshielded and the shielded twisted pair. So first of all, let's talk about the makeup of a twisted pair cable. And in order to fully explain this, I have to give you a little electrical engineering 101. And that is that if you take two electrical wires and you run them in parallel with each other, then the signal that travels along those wires is going to bleed into one another. Now, don't worry about why this happens, and I was kidding about the whole electrical engineering thing. I just want you to understand that if you run two wires in parallel, the signal will bleed from one wire to the other. The way we avoid that is by twisting the wires around each other. So what you see here in the unshielded twisted pair cable is you'll notice that there's actually 8 wires. But it's not just 8 wires, it's 8 wires that have been divided into 4 twisted pairs of wires. Gee, I wonder where they got the name twisted pair from. Okay, that's exactly what it's all about. It's about twisted pairs of cables. And we'll actually see later on in this lesson that you can have even more pairs than just the 4 of them that you have in your standard unshielded twisted pair Ethernet cable. Now you'll also notice that there are some colors to these wires, and we're going to address what those colors are for in just a little bit as well. Now, even though the wires are twisted within the cable so that they don't interfere with each other, the problem we can still run into with unshielded twisted pair is we might get interference from an outside source. Okay, you may be running this cable through, let's say, a false ceiling with fluorescent lights, or you might have to run it through a room with a generator. There's all sorts of different electrical objects out there that give off EMI, electrical magnetic interference, which can then bleed into the signal and interfere with that signal traveling on an unshielded twisted pair cable. In that case, that's where we move to the shielded twisted pair. You'll notice that the shielded twisted pair cable pretty much looks exactly the same, except for there's an extra layer of foil shielding around each of the pairs of cables. And that is to protect against that outside EMI. Now, the one last thing I want to talk to you about when it comes to twisted pair cables is, and we're going to revisit this in a little bit, but I just want to point out that you know you're looking at a twisted pair cable by its connector. Okay, you don't actually typically see the wires just sticking out. Those wires are terminated into something called an RJ45 connector. And you may recognize this connector. It looks a lot like a telephone cable connector. And as a matter of fact, I will tell you that twisted pair cable is sometimes referred to as telephone cable, because that's how telephone cable works as well. It is twisted pair cable. So the only difference between this connector and your standard RJ11 telephone cable connector is that the RJ45 is bigger. It's a wider connector, and it can hold more wires. Now, the next type of cable that I'd like to talk to you about is something called coaxial cable. Now, I will tell you that you really don't see much in the way of coaxial cable anymore in today's networks. But let's go ahead and make sure that you understand what coaxial cable is all about anyway. So the first thing that we need to know about these coaxial cables is the makeup of the cables. If you were to look at a coaxial cable, all you would see is kind of the outside of the cable, and then if you looked at the tip, you would see a little wire. Okay, and you've probably experienced this because these are the same types of cables that are used very often with cable television or with satellite to your TV. Okay, now the types of cables, as you'll see, are a little bit different in computer networking, but it's the same general makeup. You see the outside and you see this wire. Well, the reality is, if you take a look here, you'll see that there's actually 4 layers. We have the innermost copper core, and that's that wire you see sticking out, and this is the wire that the data actually travels on. But then we also have an inner insulator, which its whole purpose in life is really nothing more than to insulate between the copper core and then the next layer, which is the wire mesh shielding. So since this extra wire mesh shielding is made of metal also, it would conduct along with the copper core, and that's why we have to have that inner insulator separating the two. Now, why do we have to have this extra shield? Well, just like we talked about with twisted pair cable, all cables, all wires that deal with electrical transmissions have to address the issue of EMI. And the way that coaxial cable deals with it is by putting this wire mesh shielding around it to protect against that outside EMI. And then the 4th layer is the one that you can commonly see, which is just the outer insulator. so that instead of actually looking at an ugly wire mesh, you look at something that's a little bit, I guess it's a little bit prettier. Usually it's just a standard black or a standard white, although it comes in many different colors. So that's how the coaxial cables are made up. Let's look at the different types of cables that are out there. First of all, we have thin net, which is also known as RG58. This is an older type of coaxial cable that we used to use very regularly in just standard offices. It could handle data speeds at a maximum of 10 megabits per second. So again, we're going back to like the 1990s. It had the ability to take that data up to 185 meters before suffering from attenuation. Okay, so we could get a little bit more distance, in fact, almost double the distance that we could get with our twisted pair cables. And it used what was called a BNC connector, and I will tell you that that's a little bit redundant because BNC stands for British Naval Connector, so it's like I'm saying British Naval Connector connector. But anyway, this is a type of connector where you would slide this connector onto a peg, and you would then twist it about a quarter turn to lock it into place. Now there's another type of connector, and I don't have it displayed for you here, but it's called a T connector. And that T connector would be, if you picture just the letter T, one branch of the letter T would be connected to the network card on a computer, and then you would have two of these thin net cables connected to the other two branches, one going out in each direction, so as to basically make a straight run of cable. And you'd have computer after computer after computer, and there was something called the bus network. And we'll talk about topologies, which is where that term comes from, in another lesson. But the bus network was primarily made up from this cable. Now that I've told you all this about the thin net coaxial cable, I will tell you it was pretty much a history lesson. Okay, you don't find too much, if any, thin net coaxial cable used in today's networks. Now, along with thin net, we also had something called thick net. Thick net coaxial cable, even though it really doesn't look like a coaxial cable if you look at the picture here, because it just has this very standard computer-looking connector. A thick net coaxial cable also could handle data speeds up to 10 megabits per second. But look at this. It could actually take data up to 500 meters before suffering from attenuation. It used an AUI DB15 connector, and that's what you see listed here. And it also used what's called vampire taps, where we could have devices tap into the cable through using like these teeth that would go down to the copper core to make the connection. But here's the one main thing I want you to know about thicknet. It was used in most backbones. Okay, it was used as the backbone of a lot of networks, and the reason why is because it could go 500 meters before suffering from attenuation. And that is something that was needed back then. You'll see in a little bit here we have another type of cable which is even better than the 500 meters, which is used in today's world. But again, if we go back a few decades, we had thin net in the main office space connecting the individual computers, and we had thick net as our backbone, getting one particular office maybe connected to another office. Now there's one other type of coaxial cable that I have listed for you here, and it really doesn't have anything to do with computer networking. But as long as we're talking about coaxial cables, I want to make sure that you understand how it's related, and that is the RG59 and RG6 coaxial cable, which if the picture on the screen is starting to look a little bit more familiar to you, well, it should, because this is the type of coaxial cable I mentioned just a little while ago that we use for our cable or satellite TV. It uses what's called an F connector. And the F connector is, just as you see there, where basically you just slide the connector over the peg that you're connecting to. Now, in some cases, you just slide it on. Some cases, you actually, there's actual threads and you screw it on. But the bottom line is you just slide over the peg and you are connected, as long as that copper core makes it into the hole on that peg. Now, the third type of cable that I want to talk to you about is something called fiber optic cable. Now, there's one distinct difference between fiber optic cable and the other cables that we've already talked about, and that is that with fiber, we're using light pulses to transmit the data instead of electricity. Now, with the use of light pulses, there's a lot of benefits that we get from this. The first benefit we get, and this is one of the original reasons that we started using fiber optic cable, is that it's much more secure. Now, the reason it's more secure, and it's just you kind of have to have an understanding of how electricity works. With the electrical cables, you can tap into those cables. So if you get physical access, all you have to do is, well, there's really two ways to tap in. There are tappers where you just clamp down to the outside of the cable. And remember when we were talking about that electrical engineering 101, we talked about the signal bleed when we have the parallel wires? Well, the reason you get that signal bleed is because the transmission of electricity is actually in waves. Okay, it's actually traveling like this, and those waves are bleeding outside of the cable. So when using an electrical cable, you can sometimes just tap in on the outside and just grab hold of that signal bleed. Or if that's not good enough, well, then all you have to do is just kind of strip away the insulation. And as long as you touch another copper wire to the copper core, the actual transmission core on those copper wires, when it comes to electricity, it'll travel in any path it finds available. So that's all it takes to tap in. Now you might be thinking to yourself, well, with light pulses, light tends to travel kind of anywhere it wants to go as well. The difference is with these fiber optic light pulses, the actual carrier of the light has to be cut and polished very particularly to be able to carry the light pulses in a way that data transmission can take place. And it's for that reason you can't just cut in and touch another light carrier onto the cable. It won't work. Okay, so fiber optic cabling is much more secure. It really cannot be tapped into. Now, a second benefit that you get with fiber optic cable and using light pulses is that, well, since we're not using electricity, no more EMI. Okay, there's no electromagnetic interference. You can run fiber optic cables through any room you want to. You can go right through a generator if you want to. It doesn't matter. You're not going to get electromagnetic interference because that interference can't interfere with light pulses. Now, a couple other benefits that we get, and I don't necessarily have a specific technological explanation for you, is that it has been determined that you can also get much faster speeds and much longer distances out of fiber optic cabling with its light pulses as well. Now, you might be thinking to yourself, well, that's great. I mean, you can go faster and longer distances, no interference, and way more secure. Why don't we just use fiber everywhere? Well, the reason we don't is because there's also a couple of drawbacks that come with fiber. And those drawbacks are that it's more expensive, and more importantly than that, because you might think it's worth the budget, it's much less flexible. Okay, remember that you have this very, very sensitive light carrier. Okay, you have this really what's in the old days was all glass sheath that you would have the light move along on. These days you still have glass, but you also have some plastic versions which have a little bit of flexibility, but you can't just go running it every which way like you can with the different electrical cables like twisted pair or coaxial. Now, one more thing that I want you to know about fiber optic cabling is you'll hear it talked about with single mode fiber versus multi-mode fiber. Well, I want you to know what the difference is when you hear that. With single mode fiber, you have a much smaller carrying core, and it's designed to work with a laser-based light, and the result is you can travel very long distances. And when I say very long, I'm not going to get into specifics, but I will tell you that we're talking miles and miles and miles that you can get from that single mode fiber optic cable. The other type, which is multi-mode fiber optic cable, has a thicker or a larger carrying core. And the reason is because it's using LED-based light. And therefore, although you are going to still get longer distances than you would get from your electrical cables, it's going to be much shorter distances than your single mode fiber. Now here on the screen, you'll see that I have a number of different connectors, some of which we've already talked about, listed for you. So first of all, at the top here, you'll see that I have an RJ45. Now we talked about that RJ45 and how that's used with twisted pair cabling. And I'd mentioned back then that it probably looks a lot like a telephone wire connector. And so I decided I would show it to you in that capacity. I have an RJ45 right next to the RJ11. You'll notice that the RJ11 looks very similar, but it's smaller. We already took a look at some of the coaxial cable connectors when we were talking about coaxial cable, where we have the BNC, right, the British Naval connector for our thin net cable, our AUI DB15 connector for our thick net cable, and then the F connector, which we don't use, again, with computer networking, but we see this when it comes to cable TV or satellite. Now, another type of cable/connector that I have listed for you here on the screen, I'll be honest with you, it's one that you don't see too much anymore, and I put it there, quite frankly, because it's on the Network Plus objectives, and if that is one of the reasons that you are watching this course is because you're studying for the exam, I want to make sure you know what an RS-232 connector is. And this is the type of connector that goes onto a serial cable. This is a cable, again, that we haven't used in a long, long time. I mean, we still use it today in certain isolated circumstances with different terminal connectors and things like that. But the bottom line is it's a 9-pin, either male or female connector, and it goes with a serial cable, and it's called RS-232. Now, the last set of connectors that I want to talk to you about here are all the ones listed on the right. And we're not going to go into any real specific detail on any one of them, but I just wanted you to get a feel for what they look like. You'll see that I have the SC, the ST, the LC, and the MTRJ connector, and these are all fiber optic cable connectors. Okay, now there's a lot of details about each connector and the specifics of where you would see it and when it's used that I really, honestly, don't want you worrying about right now. The main thing that I want you to understand by all of these different connectors that we're looking at is it's pretty much the connector that's going to help you to know exactly what type of cable you are looking at. Okay, so if you can recognize by sight the different connectors, you can also then recognize by sight the different types of cables. So now I want to talk to you about using whatever type of cable it is that we're talking about in the plenum. But in order for us to talk about using cables in the plenum, we have to first understand what the plenum is. Here I have a picture of what is basically just a big empty office space. It might look familiar to you. It looks like your standard office, right? You got carpeting on the floor and you got ceiling tiles and lights above you. But what you may or may not realize is that they're usually, and I'll tell you this is true in most office spaces, that those ceiling tiles that you're looking at, those are usually ceiling tiles representing a drop ceiling. Now, by drop ceiling, we mean that there is area of space and air above that ceiling. And to be more specific, if you look real carefully, kind of behind where I put the arrow representing the drop ceiling, you'll notice there's even kind of what looks like a vent, like a heating or cooling vent. And very often that's what these drop ceilings are for, is so that you can have ductwork and stuff like that. And then also the ugly part of the lights that's all hidden above the actual viewing space for the person who has to work in the office. Now, something that's also in many offices, although not as common as the drop ceiling, is the potential for a raised floor. The floor that you stand on in your office may or may not be the actual ground or the actual floor of the building. Sometimes there will be a raised floor, so it's basically like they created a box and you're on top of that box. And the reason is because very often what's underneath you is a lot of the cables that we've just been talking about. So here, let's move away from a picture of an actual office and let's go into just a kind of a diagram of what this office space looks like. So again, you have your open office space, which is the stuff that we normally see. You have your drop ceiling, and above that drop ceiling, you see all kinds of ductwork and stuff like that. And then again, you can have your raised floor where you might have cables, sometimes plumbing, all sorts of stuff that can be running underneath the floor. If you are going to run cables in these hidden areas, especially if it's an area where Air can gather, and then especially even more so if that air can then be taken from that space and maybe thrusted into another space, especially an actual open space where people are breathing. It is important that you use what's called plenum grade cable. And the reason you want to use this plenum grade cable when working in the plenum, which, by the way, again, these fake areas, these hidden areas, that's the plenum. The reason you want to use this plenum grade cable is because non-plenum grade cable, your standard cable, if it were to burn, and in some cases, when we say burn, it could be because the building's on fire, but then again, we may be evacuating. But it could also just simply be an electrical fire. It could be the wires themselves are burning up. Well, the insulation around those wires can be toxic. The idea behind plenum grade cabling is that, and it's a little bit different depending on the exact grade that you get, the exact cabling that you buy. If that cable was to burn, the outer insulation would just dissipate into a harmless gas or sometimes into a powder. But in either case, the idea is to avoid the toxic fumes that you get from your standard cabling. Now, one other thing that I want to address here is I've had people ask me the question. I've had people shoot me a message asking about the different grades of plenum-based cabling. And I will tell you that I don't have any one specific answer for you on what type you should be using. You want to check in with a local building inspector. They would be better prepared to answer what type of cable you need to be using if you're going to work in these areas. Now let's talk about the different LAN technology types. Now, when I talk about LAN technology and networking, there's one name that pretty much covers it all. I mean, by today's standards, pretty much everything is an Ethernet network. So we're going to look at all the different types of Ethernet networks. And I will tell you that as we look at these, what we're actually looking at is kind of a progression through time. Okay, the first one that we're going to look at would be like the original or the oldest, and then we're going to work towards some of the newer Ethernet networks. So the first one we have here is standard Ethernet, which is commonly represented by just calling it 10 base T. And I will tell you that although 10 base T, it looks like I have it written here like it's one word, it's actually 3 different components that represent standard Ethernet. The first component, the number 10, represents how fast the data would travel on this network. Okay, so the 10 is representing that this is a 10 megabit Ethernet network. Now the word base, I will tell you that I'm going to give you a real basic definition of where this came from, although they're all base or baseband networks. Okay, but baseband and broadband were the 2 different types of transmissions. And back in the day, believe it or not, a baseband transmission was a very specific digital, ones and zero, up and down based transmission, whereas broadband was more of a wave or an analog type of connection. And that gets a little confusing by today's standards because lots of times you'll hear about like broadband connectivity, broadband internet connectivity, and this is also a digital connection. So I don't want you to get confused by that, but I just thought I'd tell you that's what the base stands for, is the good old-fashioned ones and zeros, perfectly digital baseband transmission. And then finally, the T stands for the type of cable. And no, the T doesn't stand for type. The T actually stands for twisted pair cable. Or some people will actually say the T stands for telephone cable. Either way, because as I told you earlier, telephone cable is twisted pair cable. I don't care what you refer to it as, but the T stands for twisted pair cabling. Now, there's a term that I want to interject before we go on to the other Ethernet technologies, and it's a term here called Ethernet bonding. It's something that we don't see as much in today's world as we used to back in the days of these 10 megabit Ethernet networks, because what happens is with Ethernet bonding, it's the idea of taking 2 or more connections, or we could say 2 or more cables, and then allowing them to act together with single transmissions. Okay, you're bonding them together. So if you want to think of the idea as you take a 10 megabit Ethernet connection and you take a second 10 megabit Ethernet connection and you bond them together to work as one connection, you theoretically have approximately a 20 megabit piece of throughput now. Now, it's not literally 20 megabits because there's some overhead that goes along with this bonding, but that was the idea of what we did in order to speed up the networks. So now let's move back into the different types of Ethernet. And the next type we have here is fast Ethernet. Now, fast Ethernet is generically known as 100 base T, where typically you'd think that the 100 represents the speed, which it does, the base for baseband, and the T would be for the twisted pair cable, right? Well, the reality is that fast Ethernet, this 100 megabit Ethernet network that we moved into, could be done either on a twisted pair cable, but it also could be done on a fiber optic cable. And that's why we have the breakdown here of 100 base TX, which was the representation using twisted pair cabling, and 100 base FX, which used the fiber cabling. From there, we move to gigabit Ethernet. And you'll notice, by the way, that we talk a lot about standards, but there really isn't much of a standard going on here, because as we move from one speed to the next, it's a little bit different, right? Because we had T for twisted pair, then we had TX for twisted pair. Well, guess what? Now, when it comes to gigabit Ethernet, we have 1,000 base T, where the 1,000 represents the speed, right? Gigabit transmissions, base for baseband, and then T for twisted pair cabling, right? If you were using your Cat 5e or higher cabling. And then you have 1,000 base X, which represents the fiber optic cabling. And then we move into something that some people still scratch their heads and say, can we really do this? And that would be something called 10 gigabit Ethernet. And there's a whole list of them that we have here. And I'm not going to go into detail on these, but basically you have the 10 GB, or I guess technically it's just 10G if we're going to split this apart here. The 10G stands for 10 gigabits of speed, base for baseband, and T for twisted pair cabling. And then we have SR, LR, ER, SW, LW, and EW, which all are variations of fiber cabling. Now, there's one last thing that we need to go over before we wrap up this lesson. And I want to tell you that up to this point, everything that we've talked about has specifically had to do with the actual cables. Whereas now, we're going to focus on something called wiring distribution. Now, in some cases here, some of the stuff we're about to go over is still cables, and in some cases, it's the things that like cables plug into. And I also want to tell you that much of this last little bit of technology and equipment that we're going to talk about, you may or may not ever actually have to deal with, because in some cases, there will be like a third-party vendor that's setting things up for you. So treat this last section almost kind of as like a vocabulary section, especially if you are looking to take the Network Plus exam, because then you will have to know it. So let's look at this last little bit now. Now, the first of these definitions that I want you to be familiar with, the first of these items, is something that is technically still a cable. It's something called a cross-connect. And this is a cable which connects you to a backbone or a provider. And what this also means is, although it is a cable, it's not a cable that you typically would be dealing with. This is a cable that the backbone provider would be hooking up, and you usually find it in a wiring closet connected to a patch panel. Speaking of patch panel, you need to be familiar with one. And there's no better definition that I could give you than to just put a picture of one on the screen for you. So that is what you are looking at right here. This is a picture of a patch panel. This is where you have connections from all around your office, which then get wired through the walls and above the ceilings and below the floor, and eventually come to the back of this panel. And then the front of the panel is where you can quickly and easily patch one of those connections to another device or another office or any type of quick moving around of connectivity that you want to do. Now here's a couple definitions for you, and these are ones that, again, you probably, or possibly I could say, may never deal with as a network administrator, but you need to know them for the Network Plus exam, is MDF and IDF. And quite frankly, they stand for Main Distribution Frame and Intermediate Distribution Frame, and it's kind of just what it sounds like. It is a distribution frame. It is a point where cabling is distributed. Now here what we're looking at is something that is used most typically by your telephone providers. Very often you might have different telephone systems, and they will go to these things called a 110 block, okay, where you'll notice that you have all these wires, and it's almost like a form of patch panel, but it's typically used more for telecommunications than actual computer network communications. And here, check this out. Does this look like anything that you've seen already in this lesson? Because it kind of should. You may recall, if we go all the way back to when we were talking about twisted pair cabling, I showed you a cable that looked just like this, but there were only 8 wires sticking out, right? And then those 8 wires were twisted into 4 pairs. And I mentioned that there are also larger variations of this, and that's what we're looking at here. I actually don't know which one in particular we're looking at because I would have to get down here with a magnifying glass and count the wires. But this could be a 25 pair or a 50 pair or even a 100 pair cable. They do exist. And again, are you going to have to deal with this at this level? No. I just want you to have an understanding that these types of cables do exist. A few more terms that we have for you. We have something called the demarc, which is short for demarcation. And this is the point at which the telephone company's network ends and your network begins. Okay, this is where it connects into your in-house wiring. So this is very often a box, sometimes that you will find outside of your office. And it's basically where, the telephone company's network goes to that box, and that box is the beginning of your wiring. Or to be more specific, sometimes we'll have something called a demarc extension, which is an extension from where that telephone company's network ends, and yours truly begins. So the extension may be to a box that's in the building or in your server room, in your wiring closet, things like that. And then we have a smart jack. A smart jack is the actual termination of a T1 line at your office. So if you have a leased T1 line from a telecommunications carrier, the termination of that T1 line coming in at your office is called a smart jack. And so that does bring us to the end of this lesson, where we learned all about the wired media. Okay, now I really want to put the emphasis on, remember, media is both wired and can also be wireless, but here we focused on the wired media. And I want to make sure that you are able to walk away knowing about all the different types of cables, what they look like, what kind of jacks they use. And then, of course, also don't forget about working in the plenum. You know, there's a lot of fire code issues you got to make sure you're aware of. So that's it. That's all for wired media. I'll see you in the next lesson.